In this video, I want to have a look at indefinite integrals. So indefinite integrals is just the more common way of saying primitive functions. So the way we write an indefinite integral is just the integral of f of x is equal to capital F of x plus c, where that capital F is a primitive function and c is the constant. So that c is really important because it's telling us that there's not just one possible primitive function, there's actually a whole family of functions that would give us this original function or that would differentiate to give this function here. Now an indefinite integral doesn't have upper or lower bounds, so we can't evaluate it to get just a number as our answer like we can when we're doing definite integrals. So when we find an indefinite integral, we're still going to have functions of x or whatever variable we were using. So let's have a look at some examples. So here we're asked to integrate 8 with respect to x, so that would just give us 8x plus c, so adding that constant on the end. Our second example has a few more terms in it. So when we integrate that, we'll just go through and do each term. So our 12x cubed will become 12x to the power of 4 over 4. Then we'd have minus 5x increase the power to become a 2 over 2, plus 1 would integrate to give us x, and then we need to have our constant term on the end. So simplifying this first term down, we have 3x to the power of 4 minus 5x squared over 2 plus x plus c. Now this next example is a little bit more complicated because of that power of 6 that's applied to that whole thing. So on your reference sheet that you'll get in every exam, under the heading of integrals, this is the first thing you'll see. And this rule is going to help us integrate this function. So the way it's going to work, what's in the brackets is going to stay the same, and we're going to increase the power by 1. So we'll have 5x minus 3 to the power of 7. Then we're going to divide by a, which is the coefficient of x, so in our case it's 5, times that n plus 1, which was 7. Then we'll have our constant term on the end, and simplifying that down, we'd have 5x minus 3 to the power of 7 over 35 plus c. Our next example, we're still going to have to use this same rule, but first we're going to have to manipulate the function that we're given. So we know that the square root of 2x plus 7 can be written as 2x plus 7 all to the power of a half. And then if we bring that up into the numerator, we could write it as 2x plus 7 to the power of minus a half. And once we have it in this form, then we can apply this rule. So when we integrate, we're going to leave the insides of the brackets as it is. So we'd have 2x plus 7. We're going to increase that power by 1. So we'd have positive a half now. Then we're going to divide by a, which is our coefficient of x, so our 2, times by the new power, which is a half. And then we have to add our constant term on the end. So simplifying that 2 times a half just becomes 1. Let's change this power of a half back to a square root, so it's in the form that we were given in the question. So we'd end up with the square root of 2x plus 7 plus c. So our next question has 2 parts. Part 1 asks us to differentiate this function here, and part 2 says hence find the integral. So let's have a look at part 1 first. So if we let y equal 3x plus 1 to the power of 5, we're asked to differentiate that. Now using the chain rule, we're going to bring the power out the front and leave the insides the same but reduce the power, and then multiply by the derivative of the inside, which would be 3. So simplifying that, we'd have 15 outside of 3x plus 1 to the power of 4. Now our part 2 asks us to integrate 15 outside of 3x plus 1 to the power of 4 with respect to x. And you should be able to see that that's exactly the answer we got for our first part of our question. So now because differentiation and integration are the opposites, when we integrate this, we're going to get back to our original function. So we'd have 3x plus 1 to the power of 5, but we have to remember to add our constant term on. Alright, so that's an introduction to indefinite integrals. And the most important new thing from this is to never forget to add that constant term.